Thanks for attending this workshop on detecting IMSI catchers and other mobile network attacks. I'm happy that you're here. I didn't expect that many people to have interest in the topic. We will present 3 common attack scenarios to you, and actually we want to explain how we do detect them with an application that this team has built. And we also want to make this as hands-on as possible, but also as simple as possible. So we'll do a short intro. I will be the idiot that does the very, very basic explanations, and then we'll go over to Luca, who is the mastermind of all mobile network research in our team. He will explain the detection logic, and then we'll move over to Dexter, who is the engineer of analysis and implementation and demonstration. There will be a little demonstration. Some of you may have noticed the demonstration already. So we will start with the very, very simple stuff, and then we'll dig down to the network level. And I hope that we don't lose too many people along the way. And if there are still any open questions afterwards, we're very happy to be contacted and asked, and we'll try to discuss whatever you want to discuss with us. So one person I haven't introduced is Jakob. Jakob is the lead developer of the little Android application that we have built. This Android application does all these detection logics that we're trying to present here. And you can download it for your compatible Android phone if it has a Qualcomm baseband. It's called SnoopSnitch, and this workshop is basically going to focus on what SnoopSnitch does and how it does it. Okay, so you don't see the slides, so I will just read them out to you. This is the introduction part, in which I show some material that was leaked, I think, on WikiLeaks and is now available on Bug Planet, and shows the attack tools and equipment that have been available for years now to law enforcement agencies and anybody who wants to buy equipment that allows them to track and intercept mobile phones. And this was just the introductory part to show you how small these devices have now become. They put them in vehicles, you know, they're very convenient setups for demonstrations when you want to intercept or track people at demonstrations. But you can also wear them as a vest. I don't know, I think that's more of a James Bond thing, but there can be a body-worn IMSI catcher, and they are now already as small as phones, right? So there used to be much bigger setups like the one we have built here. But now IMSI catchers are really small, and also by now very cheap to get. So this attack scenario is becoming more and more realistic and a threat to you as well. So that's why we've built SnoopSnitch, an open source application for Android that should help you to detect these. The 3 attack scenarios that we're trying to explain today is a location tracking IMSI catcher, which is a machine that just detects that you are there. The intercept fake base station, so an IMSI catcher that actually allows to intercept your calls and transactions, and the so-called silent SMS, of which many of you may have heard already. So let's start with the location tracking IMSI catcher. And even I can't see the slides, so I think I don't even need to flip through them anymore, but I need them as a cheat sheet. So a location tracking IMSI catcher basically is a network cell that advertises the signal that your phone is expecting and waits for your phone to connect to it. At that point, it will simply ask you for authentication, for identification. So it will collect your IMSI and your IMEI, which is a unique identifier for you in the network and for your phone as a network device, and will then send you away again. So that's as much as I have understood of it, and I'm looking forward to have Luca explain it in detail now.
Yeah, exactly like Linus said. The idea is that you want to collect the identity that is a permanent, unique identifier of the user, of the phone, of the mobile, in case you need it for attacks. Like if you want to know if it's an iPhone or a BlackBerry or Android, you can know that. And there are also other little details in the procedure that is displayed. There are, for example, you can know in which network the user was currently connected to and which temporary identifier he was using, so you can track the user after that also. The main purpose is just to collect your identity, and you will never notice about those devices, except if you're running Snoopstitch, of course. And you should have noticed, some of you, because I don't know if our antenna can reach you, some of you might have received some message. I don't know if this happened. Okay, that was our IMSI catcher. So we are proving you that we collected your IMSI. And you notice, because we are sending you an SMS, but this would be completely silent. And how do we detect this? How do we plan to detect this? Linus, can we go? Yeah, sure. You can use this even. Okay. So still, you probably cannot see it. Our logic has many criteria that work in parallel that make the detection more reliable, because otherwise we know from our measurements that it's not always reliable if you only choose one criteria. And we have many criteria there that we are using. So for example, first of all, we check if a location update was rejected. A location update is something that happens when you move from one cell to another one. And the IMSI catcher that we are using is faking a cell that didn't exist before. So you are actually moving there, and your phone can know that it's moving to a new cell. And if the cell says, no, I don't want you, you can say, this is not good. And also you can see if the network was asking for your identities, if the network doesn't do authentication, if the network doesn't do ciphering, and we have such criteria all in parallel, and they multiply into a score. And this score is saying basically how likely you have been caught in an IMSI catcher. Not only for the location update, we find some evidence. We also have some permanent evidence in the cell parameters that are set in the broadcast information of this cell, and they can be custom tailored to catch you faster, for example. So the choice of a location area that was not used before makes it faster. You could also use a real location area, but it really takes longer. You can check if that location area was used in some other place of your country, for example. That would be suspicious. If that frequency was used before by another cell ID, that's also a tricky thing to check, but we are trying to do that. And yeah, other parameters in the broadcast can be set not like the network does normally. So for example, not having neighbors. A cell that doesn't have neighbors is pretty strange. And in our case, we are setting some parameters that are out of normal. And you will be able to see all of this in what Dexter will show next. That is actually the radio traces that we can record with Snoopstitch. So
I'm not sure you will actually be able to see it, but we'll try.
Oh yeah, well.
Einmal den Ton. Jetzt muss ich den Knopf drücken, ne?
Ich habe gerade ein Problem. Der primäre Screen ist wahrscheinlich jetzt auf dem Beamer und ich habe jetzt den sekundären Screen.
Aber man sieht eh nichts.
Man sieht nichts, das ist natürlich schade. Ja, unmute mich mal. Das ist vielleicht eine ganz gute Idee, wenn man das macht. So. Ja. Geht so einigermaßen. Ja, wo bleibt denn das Bild? Das wäre jetzt mal interessante Frage.
Scaling Type, ne?
Was gibst du da aus, Dexter?
Ich weiß nicht, was ich da genau ausgebe. Es ist auch mein primärer Bildschirm irgendwie gerade weg. Ich kann es ja nochmal rausziehen und dann öffne ich mal hier mein Kontrollzentrum.
Wir müssen jetzt irgendwas sagen. We need to say something.
Yeah, so I guess even if this works, you will not be able to see the small digits on the screen. You might be able to see them when we release the slides, but I don't know.
So yeah, to fill this awkward moment, we all the traces that we're going to discuss here, we have also uploaded to our repository, so you can download them. These are Wireshark traces that you can open in Wireshark, and you can see exactly with the little instruction manual that we've created for you as well. You can see when which message is sent and in which GSM frame the phone actually jumps to the cell when it is rejected, and you can see the difference of a legitimate location request and one that is being rejected after the phone is asked for the IMSI and the IMEI. So this is what we were trying to show here now. I think we'll be forced to skip that unless the thunderstorm hits and the sun goes down. So the training material, I'll show you the link at the end of the presentation, and you can do all this at home as well. And that's of course the main part of a workshop, that you get some hands-on things to do, and that's why we've prepared the training material. Shall we head on?
Yeah, so maybe we just give 2 lines of what you can see in the traces, as Lino said previously, all the sequence of messages, and you can dig into every single detail that we crafted for making the IMSI catcher more effective. For example, setting some timers. There is a timer that is used by the network to tell to your mobile how many times does it have to do this update. So your mobile will talk to the network every, let's say, 3 hours, and say to the network, I'm here, I'm here, I'm here. And you can change it, and you can say, tell me your position every 6 minutes, for example. That would be a bit suspicious. Other parameters, you can change some radio offsets so that your mobile would prefer our cell rather than all the surrounding ones. As I said, the neighbor configuration, you can check all of this in the trace. Yeah, we can probably.
Ja, das war der Fehler. Okay, so we've now tried to discuss the location tracking IMSI catcher that tries to collect your identity information and then get rid of you. And as you may have noticed, this IMSI catcher has a design problem, which is as long as you're connected to the IMSI catcher, you won't be able to receive or place any transactions. So you can't receive SMS, and you can't receive calls, and you can't call anybody. And of course, the attackers, if they provide service to you, they're not going to give it to you for free. Actually, they are going to give it to you for free in this case, but they also want to make sure they can intercept you. And this is where the next type of IMSI catcher comes into play, which is not really only an IMSI catcher, but a device that downgrades your encryption and makes sure that your transactions can be intercepted. So here we have the standard call flow. What you can't see now is the standard call flow when a phone connects to a well-configured network. So when it connects to a well-configured network, it would say, okay, here's a location update request. I would like to connect to you. And then the network would usually say, in a well-configured network, well, I require authentication, prove your identity. I want to know if I even want you here. You may be a user of a different network, so I want to make sure that I want you here. So the mobile phone authenticates. There's a challenge response procedure there that is based on the IMSI, on the keys that are in the SIM, and by that time the network knows, okay, this is a legitimate user. And in an even better configured network, you would then have the ciphering mode command so that all transactions are encrypted and everything is fine. And then the location update is accepted. In an intercepting fake base station, you don't have the authentication part because the network, the fake network, is not able to do the authentication. And it's also not able to do encryption. In fact, it doesn't even want to do encryption. So you would connect, you would do your location update request and say, hello, I would like to connect to this cell. The cell says, well, that's beautiful. Just tell me your IMEI. Yes, here's my IMEI. Beautiful. Can I have your IMSI as well? Yes. And then the network says, beautiful, you're now connected to me. And it doesn't reject you. And then when you want to do a call, so you do the CM service request message, the network would say, fine, let's go ahead, we can do this. With the little difference that none of the transactions are encrypted, so that the cell that is providing the service can intercept everything that you're talking about.
Yes, and that's the case that you are seeing now. So we are keeping the users that we hijacked into our cell, and we are sending an SMS, of course unencrypted. You could even try to call somebody. I don't know if this works because it shouldn't work. The catch here is that no encryption. That's easy to detect. If you would see the traces later, you will see that that message is missing. So no ciphering. Authentication, yes, that's something that can be possibly fake. It depends. There are 3 cases. So you could, as a fake BTS, you could say no authentication, authentication type GSM, and you can fake that. Because in fact, you are just sending a random sequence, and the mobile is answering with another sequence, and you don't care about the response. A real network would care about the response, but you don't care. And then there is a third case that is mutual authentication that is used only for UMTS. My mic, okay. And in that case, it's a bit more difficult to fake. So that case is not present in IMSI catchers that, for example, the one that we simulate. Can we see the slide, my slide? Yeah, so as well as before, we have some criteria that are working in parallel. We have some analysis that works on the transactions, so calls and SMS that you try to send or receive. And there is some other logic that looks at the parameters of the network that are just announced by the cell. Something that can happen in this type of IMSI catcher is that not only you are still connected to this catcher, but the person that operates the catcher can try to locate you precisely, establishing a silent call. A silent call is like a call, but there is no caller ID. So your mobile doesn't display anything on your screen, but there is actually a call going on. And this helps who wants to track you to use a directional antenna and move it until they find the source of the strong signal that you are sending. This is also detected by our application. Of course, sometimes the network does that for a mistake. So in case you're paged because there is a call that was supposed to go to you, but then the caller just hanged up, and then the network takes some time to hang up your conversation, and there was actually no call. So we have to be a bit careful there, but we have some logic that should work. And so if a channel is allocated to you and really nothing was sent from the network, we think that this is very weird. Other things we can say from the broadcast, we can see that this cell is not advertising neighbors, so that you will never search for neighbors, and you will think that this is the only cell that is in this area, and you will keep your attention on this cell and will never lose it. Other things, the registration time that I was mentioning before, I think we set it to the minimum, so 6 minutes. You will continuously try to talk to us, and we will be updated on your presence or not. And we use some tricks for keeping your mobile here, changing the perceived signal level, so the reselect offset. All of this is all summed up, and then if we reach a score that we think is relevant, then we will show an alert in your application saying this can be an IMSI catcher. And I don't know if you are running, any of you, the Snoop Snitch right now. You might have, I mean, Jakob was just running it and he found the alert. These alerts are, as I said, there is a score. The score goes from 0 to at least 11. There is no limit. And if you detect something and the score is around 3, you might be detecting some normal anomalies of the network, let's say. But we will see that with our configuration, you will get a much higher score, and that's the real catcher evidence. I think the logic was described. Would be nice to see the details. So in the trace that Dexter has there, you can see all the messages that are not sent or that are sent, and all the parameters that I talked about the cell broadcast. Yeah, so something tricky, for example, is to set the correct location area. So here I didn't check before, but there can be, let's say, 3 location areas that are surrounding our camp, and we choose one location area that is actually not used in the camp, so that you are attracted to this location area, and you could easily say, looking at the history of your mobile, that's a single occurrence of that location area. There is a single cell, single location area, and you can say, okay, either I'm just entering a new location area, or this could be an IMSI catcher. So this is part of our logic there. Yeah, so this is what regards the IMSI catcher that is able to track you, sorry, to keep you. And yeah, no chance of seeing it. Well, yeah, okay. We proceed with the next scenario.
So I think we should mention, so the IMSI catcher that we're running here is targeting users that are in the camp network. So we're not intercepting or tracking on any of the standard mobile networks because we think the legal trouble we're in with this is already big enough. In order to receive the SMS or to test your Snoop Snitch phone, you would need to run on the camp network SIM card and have a camp network number. Who has one here? So, oh, okay, so there's many. And who of you has received the SMS that notifies you of your IMSI? Okay, beautiful. So those were the ones that are caught. If you now have an Android phone, you may try to install the Snoop Snitch app and operate the phone again, and it should alert you of what has happened to you. It will alert you.
Yeah, so I know that because I was testing the catcher before, and apparently, since the signal of real networks is so weak, your mobile is constantly looking for a network, and it thinks that this is actually a foreign network, and it tries to connect there. And in this current setup, we are not really rejecting you, so it can happen.
Okay, let's get to the third attack scenario that doesn't really require an active equipment on site, and that's the silent SMS. Silent SMS are a very interesting concept because they only became so popular with law enforcement because of the legal regulations that forbid what silent SMS are doing. So silent SMS are a means to track your location at all times, and the law enforcement agencies can't really request the location data from users as long as they're not doing transactions. So the idea was born to just initiate transactions to your phone all the time and then later collect your transaction records, because that's something law enforcement can do. So they just send you SMS that your phone doesn't display, and at the end of the month, just collect your call records. And with the call records, they can collect from which cell you were being served. So that helps them to collect where you've been at the time. And that is a very commonly used technique. Our friend Andre over there regularly reports on the use and abuse of this technology in Germany, and I think the numbers of silent SMS that are being sent are increasing yearly. And of course, this is just a standard behavior by the phone, not to display the message. The phone just does what it has been programmed to do. But with the low-level access that SnoopSnitch has to the baseband, it will see these messages and alert you about them. So there are three parameters to an SMS message that help you identify a silent SMS, and Luca is going to present them to you now.
Yeah, there are many parameters that are encapsulated in the radio message that carries your text. And some of them are very old, like they were defined in the standard and not very commonly used, but they have a lot of power. For example, there is a protocol identifier that says to your mobile, please discard this message. Or please receive the message, send me an ACK and discard. And the same applies for the DCS. The DCS has another role. It was designed to set an icon on your screen that says you have voicemail. And there is, of course, another command that says disable the icon on your screen that says you have voicemail. And of course, you don't have a voicemail, so we can send this message anytime, and you will never see anything on your screen. And it's an SMS that will never be displayed. A third possibility is to use port addressing. This is something not common. So when you are sending SMS, you will never use this feature, but there is this feature in the standard. This feature is used, for example, by iMessages, all the I stuff, voicemail, other applications that are running on your mobile, and they use a specific port addressing, like the internet ports, let's say. And if you use such an addressing to a port that doesn't exist, your mobile doesn't know what to do with that, and it discards the message. So you can use one of those ports as well to make an SMS invisible. We look for those values. It's a bit difficult to, I mean, we could say all these combinations are silent SMS, but that's not actually true. And we put some effort in detecting the most common configurations that are used by operators to send you voicemail or the Apple stuff. Or there is another category, there is binary SMSs that the network send you for updating something on your SIM card. Let's say your favorite roaming partners. So what the SIM card would connect if you go abroad. That's something that the network can do, and it's completely invisible to you. So we detect all of them, and we try to analyze if they are supposed to happen or not. And do you have the other? Yeah, I wanted. Okay, these are the services that I mentioned before. So all the Apple services, WhatsApp as well does that. There is some WAP push. So when you connect for the first time a SIM card with a new mobile, the network usually sends you a configuration message to set up your internet settings, for example. That's the binary SMS that is not visualized as a normal text, but of course you will get some alert like, your network wants you to set these parameters. Would you accept? Yes. But there are other types that are not visualized. So this is what is inside SnoopSnitch. There are three main criteria, so PID, DCS, and port address. They are implemented and tested, let's say. And there are other options that we are thinking of implementing that are more difficult actually to test and to make reliable. So for example, you could check that who sends you the SMS is sending you the SMS through your SMS gateway, the SMS gateway of your mobile operator. And you could check if the SMS comes from another one. That shouldn't happen. But we cannot ask you for that number. It's a bit complex for a user to know in advance what is the SMSC. But we will try to implement this in the next versions. Another thing that we could do is inspect the payload. So the content of your message. Usually silent SMS have no content, so length 0. That's very suspicious, I would say. But they can also have some unreadable text. So for example, I don't know, Chinese characters that are not displayable, or other binary payload that is not usually displayed by the phone. So there is some space for investigation there. And another thing we should do is try to understand if you receive such voicemail notification after you actually missed a call. That's a bit complex. We will try to see if we can do that. That would help to limit the false positives that we might detect in some countries. For example, in Germany this doesn't happen frequently, but in the US, operators usually send you this voicemail notification, and that causes some false positives. We will try to avoid this. Did any of you try Snopsit before? Yeah, okay, good. Yeah, we want to know from you if you ever detected such events, or if you maybe already just submitted something to our website, and we will do some analysis with you if you want. And it's important if you want to understand this, you can see this in the traces that Dexter produced, and will be released together with the slides.
Okay, as we had to skip the major part of the workshop, we have come to an end of the slide deck, and I suggest we now just move over into the shade. And those of you who are interested are welcome to join us in looking at the catcher setup that Dexter has built, and also look at the detection routines that we wanted to show you here. So we can deep dive now into detection algorithms, and I suggest we just do that in a smaller group in the shade, because honestly it's quite hot up here still. So thanks for the main presentation, and please join us in the smaller workshop group now.